All right, today this video is going to talk about section 1.1, which is Venn diagrams and some set theory. Set notation, sample spaces, Venn diagrams. So our objective is to be able to identify union, intersection, and complements using both set notation and Venn diagrams. So let's dive right in. All right, we're going to look at our notes, a couple of pieces of vocabulary. What do we mean by sample space? Set of all possible outcomes for a chance process. Okay. What do we mean by an event? An event is really a subset of the sample space. So it's an outcome or set of outcomes from the sample space. And what do we mean by complement? Well, we have three different notations for the complement. We have that, and that. The complement is really the not. So when we look at this, we want everything that is not in A. So that means everything that is not in A, not in event A. And really, these mean the same thing. This also means complement. So complement is everything that is not in A, right? And we can use the word not if we want to. But these are going to be the most common notations that we have. So not in A. So all outcomes in the sample space that are not part of event A. All right, so when we write A complement, it's everything that's not in A. All right, so a couple of different examples that we have here. If we flip a coin, two-sided coin, there's heads and there's tails. So our sample space or our possible outcomes would be heads and tails. If we set up an event that is just heads, that would mean that the complement would be the tails. Remember, that's also not B. So if you're not heads, you're tails, right? When you toss that coin. When we roll a six-sided die, now if we don't say otherwise, we assume it has six sides. There are six possible outcomes, the numbers 1 through 6. That's our sample space. All the outcomes, all possible outcomes. If we set up as our event, E being the even numbers, event E is the evens, then we have 2, 4, and 6. And then the complement of that, or the not E, remember this is the same thing, they mean the same thing, would be the odds, 1, 3, and 5. If I asked you to choose a letter from the word probability, sample space, or the list of all possible outcomes would be right there. All possible outcomes. If we set up as our event, event V is the vowels, O, A, I, and Y. Notice they're using Y as a vowel here. Then not V would be just the consonants. And we're going to jump into the next part of it where we're going to look at some Venn diagrams. So these are the Venn diagrams. Now we're in the part where we're getting to the Venn diagrams. Now notice what the Venn diagram has. It has a rectangle, okay, rectangular outline, and has some circles inside of it. So there's our Venn diagram, our first example of a Venn diagram. And what we're going to show you is what the union looks like. So the union of an event A and event B. So the U right there means union. And I'm just going to label this one over here so that we have the label right next to it. This is A union B. So what we do is we take all of the things that are in set A or event A and we combine that with everything that's in set B. The union is everything that is in A or B or both. So when you see the union, you want to think or. It's in one or the other or both. That's the union. Basically, you are putting the two sets together. You are combining two sets to make a bigger set. Union combines two sets to make a bigger set. On the other hand, intersection, and the notation we're going to use is the upside down U. Notice it right there, upside down. That's A intersection with B. So this is a picture of A intersection with B. So the words I want you to think of are and. So it's A and B. It's things that are in both. You look for the overlap. You look for what they have in common. So when I look at A and B, this is the piece that they share. So there's the intersection. That's the overlap, what they have in common. All right. So all of the elements that are in A and B, it has to be in both. So the intersection is things that are in both. If two sets don't have anything in common, and that's possible, if I looked at evens and odds, they wouldn't have anything in common, the intersection would be the empty set. The notation for that is here or there. You can use either one. Notice there's nothing in those set brackets. That's the empty set. But here's another notation for empty set. All right. Now, if we want to write everything in A that isn't in B, we have three ways of doing that. We take the things that are in A and not in B. So you have to be in A and not in B. Everything in A that is not in B. We can also write it as A intersected with not B that way. And my personal favorite is everything in A, but you take out and throw away the stuff that's in B. So what we end up having, picture-wise, is everything in A that is not in B. So you're in A, but you are not allowed to cross that border into B. And B is right there, yes? That's the B circle. We can't go into B. So A and not B. That's this notation right here. So A, but not in B. Everything in A that isn't in B. Okay, let's move on to the bottom where we're going to practice with some of this. Shade the appropriate portion of the Venn diagram. So for number one, we're looking at A complement. See that little C right there? A complement, which is everything that is not in A. So you're going to shade everything in that sample space. Remember, the sample space is the whole rectangle. We're going to shade everything that's not in A. Which doesn't mean you're just shading over here in B. You're shading everything that is not in A. So we're going to go all the way around A and shade everything that's outside. Okay, everything in the sample space that is not in A. So we're going to have this. And I'm just going to shade it really fast. And try to stay in the lines as well as I can. Okay, everything in the sample space that is not in A. Kind of got in A a little bit there. Okay, so there's A complement. This one says you are not in A intersect B. See that not right there? You're not in A intersect B. So what I'm going to do is I'm going to find A intersect B, and then I'm going to shade everything that's not inside that. So A intersect B is that little region in the middle. I'm going to shade everything except that, because it's not A intersect B. All right, we're not in the intersection. Again, I'm going to try to do this fast, but I'm going to shade all of the stuff outside of A intersect B. So we get this. All right, next. Let's take a look at number 3. So everything that is in B that isn't in A. So you're in B, but not A. So you're in B, but you stay outside of A. So what that's going to look like is everything in B, but not A. So we're going to stay inside the B circle, but we have to stay outside of A. Remember, that is the same as B intersected with A complement. Remember, it's the same. B intersected with A complement. So you're in B and not in A. They're the same. Okay, number 4. We're going to now make it more complicated. Our Venn diagram now has 3 circles. We have circle A, which is here. We have circle B, and we have circle C. Now for number 4, look at what we have. We have a union, which is combining the 2 sets. So we're going to take set A and we're going to combine it with, or put it together with, or shade it with C intersect B. It's everything that's in A or C intersect B. So I'm going to find C intersect B. It's right here. I have to shade that because it's everything in there together with everything in A. So everything in A should be shaded. Everything in C intersect B should be shaded. So we're just going to shade that up. We're taking everything in A and putting it together with everything in C intersect B. So we have this. And we're done. All right, number 5. Notice the minus sign. So that is everything in B, but not, or take out, so you can't go into A union C, right? See that minus sign right there? And this is A union C. So we're doing everything in B, but we are leaving out anything that's in A or C. So I'm going to draw the circle or the outline of A union C. There's A union C. I have to stay outside of that boundary, but I have to stay in B. So I'm going to shade over here. Everything in B that is not in A union C. So in B, not in A or C. There we have it. Number 6, the last one. We're going to take B union C complement. Notice that little complement right there? B union C complement. So everything that is not in B union C. So we're everything that's not in B union C, and you're going to put it together with everything in set A. So everything that's in B union C together with everything that's in set A. Not in B union C. Let me make sure I clarify that. Everything that's not in B union C, so here's B union C, but I want to stay outside of B union C. Everything that's not in B union C, that's a lot. I'm going to shade that, and then I'm going to shade all of A as well, because I'm putting the two sets together. Union right there says put the two sets together. So we'll shade everything that's not in B union C. It's going to take a minute. My pen doesn't want to be working super well right now. Okay, so everything that's not in B union C. And then we have to make sure we include everything from set A. So right now I'm missing a few things from set A, because set A is this ring right here, so I have to include all of this from set A. Combine set A with everything that's not in B or C. But I have to include all of A, so I am getting some of B and some of C. Okay, moving on. Back page. Example. We have this sample space. In that sample space we have 8 things. A human, a cat, a dog, a whale, a bird, a frog, a iguana, and a worm. And event A is going to be identified as animals that walk on 4 legs. Event B is mammals. We're going to list the things that are in each event. So for A, and then we'll do B, and I'd like you to put them in those fancy set brackets, just kind of like you're making an S, but you curve back around. And we're going to do for the 4 legs, let's see, that would be the cat, the dog. Whales don't have legs, birds only have 2, frogs have 4 legs. They hop more than walk, but that's okay. The iguana. And the worm doesn't fit in there. Okay, so mammals. Event B is mammals. What do we got? We got the human is a mammal. Cat is a mammal. Dog is a mammal. Whale is a mammal. Bird, not a mammal. Frog, not a mammal. Iguana, not a mammal. Worm, not a mammal. All right. Venn diagrams. We're going to draw a Venn diagram. I'm going to put it right here. And in my sample space S, I'm going to put an event A, and I'm going to put an event